Hey guys, my name is Tyson Kunovsky, and that in the striped shirt back there is Colin Young. And I'm one of the founders, along with Drew, of Lambda Consulting. And today we're going to talk to you for a little bit about our experience of building out a really interesting application. So this is a web app and mobile app that shares around 80% of their code. Now, we know we're not the first shop in town or the first people to do this. Due to the complex nature of what it is that we are building, we thought it might be interesting to give you a little bit of insight into our process and techniques we use to make this happen, so you can kind of have an overall understanding of how we did this. So quick disclaimer, this app is still kind of under active development. You might see things that are a little bit wonky, things that I still want to implement, like reselects and touch reducers directly, but I've had to obfuscate some of the code just for confidentiality reasons. But I think you get the gist of kind of what it is we're doing here, how we use things like higher order components, which we'll talk about in a great level of detail, things like React Native Web, which is a really interesting project started by some folks over Twitter, various design patterns in order to all make this work nicely. So I'm also sure that there's many different ways of doing what we did. So rather than pushing a new paradigm in development, we just like to show you what's worked for us so far, and also explore some of the common pitfalls associated with building out an app like this that reuses some of the code. And of course, if anybody has any questions, please raise your hand, let me know. Happy to answer that. Okay, cool. So before we start, again, quick, super obligatory blurb about Lambda Consulting, Chicago-based consultancy. We do kind of web, app, desktop, mobile development for large enterprise companies and startups as well. We also have our own SaaS products that we kind of build and sell to enterprise companies around town. So if anybody is interested in learning more about us, what we're up to, we're always hiring, I'm sure, like everybody else. Feel free to come grab me, Colin, or Drew after the talk, or add us on LinkedIn, and we can go from there. Okay, cool. So let's jump in. So I think it might be helpful to give you guys a little bit of context as to the problem that we got approached with, kind of the desire to build this out. So this will help you kind of see the big picture of what it is we're doing. So about a year ago, we got approached by a company that does IT management for construction companies. So a construction consulting management company. And they had this existing cross-platform application built on Ionic and Angular 1, and unfortunately the .NET stack that allowed construction workers, so people like laborers, foremen, welders, plumbers, etc., to track their information in the field. So they enter hours, to track expenses, to keep track of equipment, etc., so that kind of the back office payroll staff could very quickly and efficiently manage the process and ensure that people were getting paid and that everything was good to go. So there was the requirement that this be a multi-platform app, so iOS, Android, web, desktop, and tablet, which is obviously a lot, because different types of users need to track information in different kinds of ways in different contexts. For example, a foreman for a company might be given an iPad and be expected to put a safety checklist for a job, for a UI that was optimized for their large hands. We all know that construction workers have massive hands. So, or conversely, a laborer for a company might be given an Android phone and expected to enter their hours on it. So basically, this app was highly complex and completely configurable by company. And even more specifically, by role within the company. So for example, the process of entering hours for one company in the system might be completely different than how another company entered their hours. Or one role in the application might utilize a similar UI in a different way. So this extended from everything to kind of UI logic, to what fields were shown on the page, to how information was presented in the database. So this is probably one of the most complex apps that I've ever seen, just due to the sheer nature and amount of customization for a company on the system. It definitely wasn't a run-of-the-mill CRUD app, and it's definitely not how I'd recommend building a SaaS product, but oh well. So the reason we got involved in this project was the existing app was made by an offshore team. And after we went in and audited the code quality, we found it to be absolutely garbage, shocking. They were having massive maintainability issues. There were absolutely no unit tests, which is never a good thing to see. And when we changed something, or rather when they changed something in one part of the application, sometimes it would have far-reaching repercussions. So it might break something for a different client entirely or for a different role. And it was just pretty hairy. So long story short, skipping forward, we convinced them to rebuild the application using a modern stack. So I'm sure you guys are familiar with some of the technologies up here on the screen. It's React Redux after all. But using React, React Native, Redux, and of course all the wonderfulness of ES6. Things like Expo and Electron, which Colin's going to talk to in a little bit, our API and services layers just in Node Express app. And then of course the Webpack for our module bundler and build tool. So we basically chose the stack because we knew that we would need to be able to reuse code since the app needed to function in all these different platforms. And conceptually, we understood how to do this. There's some of the techniques that I talked about, like sharing reducers or higher order components, but we never really had any direct experience ourselves building out anything this crazy. It's a very complex application. So before we started, we wanted to do a little bit of research to make sure we weren't crazy. So at the time of the project, this is about a year ago, we found a couple of really helpful resources that I would recommend checking out to anybody who wants to try and build an app of this kind. The first was this article, I'm not sure if you can see, it was, I think, released on January 29th, 2016. It's a little bit older, but basically a company needed to do this. This was their strategy of how they went around and decided to organize their application structure and share things. So we very much kind of copied what they did. And the second was, I believe it's pronounced the SD framework, which is an awesome project on GitHub. It has like 5,000 stars. But it was pretty complex, and we didn't really need all the bells and whistles associated with what the framework did. So rather than going off and taking a Ferrari to solve the problem, we decided to kind of just roll our own solution and build our own simple system for doing this. Okay, cool. So how did this all work? How did it come together? How did we structure our application both on the API side of things and on the client to allow us to build a highly dynamic application that can be very configurable in different ways for different companies? So let's start with kind of the API side of things just for context. I'll talk about this in a second, but suffice it to say, in order to render completely different UIs for different companies and different roles, we created on our API a system of JavaScript files that lets us declare what needs to be rendered and how. So basically on login, depending on your company and your role, we fetch a JavaScript object, or really just a series of JavaScript objects, one for each page of the application, one for each module, and then use the information present in that to dynamically create the page. So you can see here an example of one such module. And I got the feedback last night that these slides are really tiny, so from now on, if you see code, the left side for you guys is the top, and the right side is the bottom, just split up into two chunks so you can see it easily. But nonetheless, you can see kind of what one of these modules look like here. I'll get to specifics in a second. But the reason we really like this is because it completely decouples the front end from the back end. So the API holds all the configuration for what needs to be rendered, kind of like a CMS, but for the pages of your application. And then the front end's job is to simply render. So there's a complete separation of concerns in this sense. It's extremely important when you have a dynamic application like what we have, because things need to be very specific in very specific ways in different contexts. And if we were to try and hard code some stuff on the front end, we'd get out of hand very quickly. We'd end up having a lot of client-side UI logic specific to companies and all this stuff that we just don't want to do. So big separation of concerns is really awesome. Another advantage of the system is that say that this company, our client, goes off and they assign 10 more companies to be on the system. So in order to get another company in the system, it's as simple as copying and pasting one of these modules that we have in order to go off and then make any changes that we need. And let's talk about how this works. This is very abstract, so let's get specifics of how this all comes together so that we can have a good understanding of how the front end side of things works. So on our API over here, we can see that we have one of our configuration files. So this configuration file is a collection of objects that represent form fields. You can see that each one has something like a component type right here. So we have a single date picker. We can even have components like a form section that themselves can have subcomponents which will recursively render themselves based on need. We have different things like a basic input. We have things like labels, right? All these different component types. We can then also put in rules for how things need to interact into this configuration. So the front end doesn't have to worry about it with rendering. We have rules here. We have things like style keys, things which I'll get into in a little bit, lookup props, all this fun stuff. So kind of how this works at the front end is when a user logs in, we go and we fetch the information for that user. We get back this big JavaScript object of different modules that we need to render. We then have utility that's going to go for each of these modules and dynamically select a reducer based on the idea of the module that we configured. So let's take a look at what that looks like. For the purposes of this conversation, we're just going to stick with this safety observation module because it's pretty simple. I think it will give a good understanding of what it is that we're talking about here. So you can see that from our action safety observation right here, we're importing this receive safety observations module data action. We're then switching on the module, or rather the action ID right here. And depending on the module that was received, we then return an action, which we then batch dispatch. And if you guys aren't familiar with batch dispatching actions, it's something that is really powerful. And Colin will get into a good amount of detail in a little bit. That is just a huge performance boost. So basically, the app loads, user logs in, we get all the modules, and then we're able to dynamically populate the necessary reducers that we need with the correct module data based on what module it is. So let's take a look at the front-end project structure here, because this might be a little bit indicative of how one would structure this themselves. So looking at the front end, you can see like any app you've ever built, we have the source directory. Within the source directory, we have three different directories. We have common, native, and web. So the common directory, as it sounds, is the place where any code that is going to be shared throughout both native and web, or rather the application as a whole. So we want to put things in here like actions, like reducers, like higher order components, like utils, and there's a bunch of other stuff here you can see. And then native and web respectively, we can use to override things. We can use to put different types of components that need to be rendered differently on web or on native. We can put different configurations, etc. So it's kind of how we're able to structure this. So I'm going to talk just about that. I'm going to let Colin talk about the whole. So just for a context, I'm sure you guys are all aware of how the React app is bootstrapped comes for us. But for our app, up here, kind of the top notch shown, we're importing just index.html file. In there is this div ID of app, like the React app has, the React app has. And then we're simply, in that element here, rendering our app here. So we can take a look at some web routes here, continue. Again, for the safety observation page, really nothing crazy going on here. I'm sure you guys have all seen this. We have a route that matches for the safety observation route that gives a safety observation component. But notice, one thing is these are web routes here. So you can see that this safety observation page is located in the common directory. If we take a look at the actual safety observation page, we can see some really interesting stuff is going on. I hope that that's big enough to see up there. Can you guys see the code up there? It's a little bit small. Okay, let's see if I can make this bigger. All right, well, unfortunately, I'm not sure I can make this bigger right now, but I'll sit over here so we can kind of take a look, and I'll walk you through it if you can't see. So right up here, we can see that we're requiring, remember this is within the context of these web routes, a bunch of stuff from React Native. So what the heck is going on here? If we look down right here, we can see that, or rather up here, we have view, platform text. Right here, we have this view that we're then rendering our render method of the safety observation class. Over here, we have some text. So what's happening is we've aliased React Native Web to React Native in our Webpack config. So anytime we require it, we're actually requiring React Native, which is extremely powerful. So this allows us to React Native Web, which Colin will also talk about in a little bit more detail later, so I'm not going to get into too much now, but allows us to essentially write a view, which in the context of a native runtime is going to be that native component, or in the context of a browser is just going to be HTML. So view would become a div tag, for example. Really, really cool project. We'll get more into it in a little bit. But suffice it to say, that's how we're able to kind of require React Native stuff from here. And then a couple other interesting things to note are these other components. So if we take a look here, we can see that we have a couple different kinds of components for application. The first, and I'll start with the bottom components, are just common components. These are things that are written in React Native Web that are going to be utilized equally in the exact same way for both platforms. But, as I'm sure you've guessed, there are examples of things that we need to have different on different platforms. So, for example, every app needs some sort of loading indicator, right? Every web app. And we don't get that for free, but in native code we do. So right here we have this loading hexagon, which is just our fancy loading indicator. If we take a look at what this looks like, we'll see that it's prefixed with this @universal symbol, which, depending on the context that this app is run, will default either to native or to web. So very powerful. We're able to dynamically require things as needed in order to render the correct element that we need to render within the correct context that we're rendering. So taking a look at a component like the loading hexagon, right? So on the website of this is the loading hexagon. Super simple div with a bunch of spans that have class names applied to them that we can go style with Sass and do whatever we need to for the web. Conversely, on the native side of things, an activity indicator is something that we get for free from React Native. So all we're doing is we're going in and requiring this activity indicator. If we take a look back here, we can see that we're using some of these components, these universal components in our app, like a generic button right here, but under the hood, they're really different depending on platform. So this is achieved by kind of aliasing React Native Web to React Web in our Webpack config. And then a common component, again, apologies for the size down here, but again, a common component, which is something that's going to be used always, no matter what, whether it's web or mobile, is just written strictly in React Native Web. So you can see up here that we're importing this view from React Native, and then down here in the actual render method, we're just returning a view that has a wrap form, which is just a fancy Redux form that we created and thrown in here. And a couple nice things are, we see that this view also has class name, right? So in the context of web development, for debugging purposes, it's really helpful to be able to see a class on a component. Otherwise, it's just a bunch of React Native gobbledygook and it doesn't make any sense. So for debugging purposes, that's awesome. And for native code, this actually just isn't going to make it through or have any impact whatsoever on what it is that we're doing. The real trick how this all works, though, is through the use of higher order components. So show of hands, how many people in here are familiar with higher order components or have used them in their development? Okay, cool. So a good amount. So a higher order component, for those that don't know, is simply a function that takes in a component and then returns that component and can do a bunch of fancy stuff to that component. So within the context of our application, I know that we could be using fancy DSM decorator syntax, I just haven't done around doing it. But in the context of our application, this is how we utilize higher order components here. So higher order component in practice, you can see here, here's the safety observation higher order component that was just decorating this safety observation component. Looks like this. So basically we have a bunch of methods that are going to go and do a bunch of logic or look up things. You can see that as an argument, this is simply a function and it returns this class, which is a wrapped safety observation component. And then within the context of this, we have things that we can do that are really interesting, like massaging props. So we basically pass into or hijack props that we want to do certain things in different ways. We pass them into a component that's rendered. All that's being rendered from this higher order component is this one line. Is this wrap component with massage props. So into massage props, we can put whatever the heck we want. We can also then decouple and have all the logic and all connections to this component within the context of the higher order component, so that we don't have to have any of the lower down components be connected or have to kind of deal with that. So we then map state to props just like you would with any smart component. And then finally, we return this kind of safety observations higher order component. One really, really cool benefit of higher order components that I would like to touch about also is we can just keep going here, right? So, for example, we need within the context of our app to do all kinds of fancy searches for various data for construction workers. So we're able to then go through, and decorate this component itself with this rapid safety observation component within another higher order component. And this higher order component is able to then pass very idiosyncratic specific things to the component that's going to allow it to do things related to searching for data. So very, very powerful design pattern. And this is agnostic, right? We're not requiring React Native, we're just requiring straight React. So there's no context for web or mobile or where this is being run. It's simply a React component, very, very powerful. So one of the really interesting things to talk about in the context of an app like this is styling, right? So how do we actually style this to work differently in different platforms, in different contexts, for different companies or users? It was a really big challenge. We had to spend a lot of time thinking about it. So what I'm showing you now is kind of the first slide that we took a look at, which is the API config for our module data. So we can see that we have these properties, and what we decided to call them as styles keys. Styles keys, which essentially map for a specific component. For example, for this single date picker component, they map different styles to aspects of the component that we can then specify that will then dynamically be rendered by styles in the front end. So let's talk specifically about what that means. Say for the single date picker component, we have a style for component wrapper, which is field.wrapper.full-length. Well, on the front end, and we'll get there in a second, in fact, we can take a quick look at that. On the front end, we would have something like this. We see that we kind of have like a string key here with a value. So if we go back here to the single date picker, and by the way, we try and keep these as generic as possible so we can reuse them as much as possible to not duplicate style code, we can see that we've assigned a component wrapper for a single date picker for this one specific module, for this one specific company, this key, which we can then go off and have just be referenced to styles on the front end that we then would need to apply to them. Likewise, for this basic input component, which is in this single date picker, we simply are able to give it a text center key, which then again references something over here. The real magic of how this all comes together and works, though, is that we break this down into platform-specific styles in conjunction with base styles that will be applied no matter what. So, for example, if we have a page on our app and the background needs to be gray, well, it probably needs to be gray no matter what, whether it's an Android, iOS, tablet, web app, whatever it is. So we're able to specify things like background color there. And then within the specific platforms, so web, we're able to do any sort of other override styles, any styles that need to be specific to web. And likewise for native, we're able to go through and actually put together styles that we need. And lastly, kind of how this works is we have this nice utility function that's going to go for all of our styles. We have, I think, 10 or 15 different pages that each have styles associated with them, and basically merges down these platforms. So we can see first here that it's checking if the platform is iOS or if the platform is Android, and if it is, it's merging in the native styles for that. And we can even get more granular. If we want to do iOS or Android, and I don't have a screenshot up here, we could have iOS or Android styles specifically be applied that would allow us to go off and have those Android or iOS only styles be applied to a specific component. And then obviously down here, we can have the base styles that are merged in, along with the platform-specific styles, so that platform-specific styles will override any base styles, taking precedent on what that looks like. So I'm going to give it over to Colin to talk a little bit more about the mobile side of things. We've got a lot of exciting stuff to cover about Expo, about Electron, about other stuff that we can get into. But in closing, a couple of important points. Higher order components, a component that just takes, it's a function, takes in a component. You can massage props, hijack props, do a bunch of stuff to it, contain all your logic there. Really instrumental in building an app of this kind. When you're trying to build a really highly dynamic app, and I know this is probably overkill for a lot of apps, the configuration of the APIs work really well for us. And that way the front end just renders the configuration, right? It's completely separated. The back end, we can even have a non-developer edit it if they want to go and add another module. They can go copy paste. Obviously, we'll check to make sure it's good, but it's super powerful in that way. And lastly, common components are written in React Native. So that's kind of all I got for you guys. Colin, you want to take it away with some of the mobile side of things?
Yep. So I'll jump on it.
Awesome. Do you want me to change the
Yeah,
slides?
I'll
Okay, awesome.
signal at you.
Cool.
Hi everybody, I'm Colin Young. I also work at Lambda. I think you did a great job of introducing the company, so I'll just let that fly, but I'll just Colin, I'm a senior software engineer at Lambda. Like Ty, been working on this project since we started it. And I've been working on React prior. He had been pretty much exclusively working on React Web, and I've been pretty much exclusively working on React Native. So we kind of had a really nice marriage of those two worlds together with this application. So I started with React Native. I had to learn a lot of the special things about React Web and vice versa. So I thought that was pretty great. And I'll try to touch on some of those things because for those of you who are at a slightly different level with the different platforms, I'll try to talk about what we just went through. So I'm going to hit next. So first of all, I want to talk about how we're deploying these apps. So obviously the web app is deployed with a yarn build, and then that gives you a zip file that you can then upload. We deploy via Elastic Beanstalk. It's all continuously deployed, service CI, and all that kind of stuff. But the benefit there is that we have a build system that can build for this. We have different environments. We have edge, staging, and prod. And each time that you build master, it can build for both of the platforms at once. And so one of the things, though, that I want to talk about is how that's done. So right now, we have the Expo XDE. XDE stands for Expo Developer Environment or something. And this is the front end, but it also has a command line utility. It's called EXP, and that's what the Service CI uses to deploy. So as you can see here, we've got the application running in the iOS simulator, and then we've got the logging here. So this is the logging from my simulator. You can see it says, it's really small, but it says my CMY MacBook Pro. You can very easily, using this thing, you can actually load up the application. You can actually load up the application with an Expo client that you're able to download, which it actually installs onto the simulator for you. Has any of you ever used Expo here? I'll try to be a little bit, okay, great. Anybody else? Yeah. Cool, so not many, which is cool, because then I can kind of talk about it. But the cool thing is you can actually kind of like scan the QR code, and then it'll actually load. That one's not going to work because this is pointing to an ngrok link that's running on my computer, so I will actually use a real one. But it opens up a tunnel so that you don't have to try to worry about like getting your IP addresses lined up and stuff. It opens up a tunnel, it's all free. And so the easy way to develop is to, if you want to run it on your device, you can just scan the code. And I know QR codes are super lame to even say that. It's funny they say, open your projects without typing. They used to say, like, we know it's lame, but it works. The Expo core team is really cool. They're supported by Facebook. They make their own front-end components, and they kind of support them. You used to support them a lot more. You can jump into their Slack and just be like, I can't fix it. And they would like totally help you. But nowadays they're kind of bigger. They have some new people, but they've all been deeply integrated with React Native at various points, and as well as React Web, and also like things like Redux. So they're a great resource in and of themselves, and they've helped us as a good choice in that method. So obviously you can run on iOS Simulator and Android. We use Genymotion. For the love of God, use Genymotion. I can never get the Android Simulator to work. So I just wanted to show you guys. So this here matches that. Obviously, I can log in. I did this via a public application. You can make your applications private, or you can find them. They used to have this store, which they just removed. It wasn't a store, it was just a way that you could actually search for Expo apps that are all public and published. That has since been removed, which is kind of great for those of us who do consulting and we don't want to share those things. When you do develop, what happens is you have an extra file called exp.json, which is a lot like package.json that allows you to basically say all of these different things. So you can see this big long string of JSON. That's basically the different configuration options. You can kind of barely see it, but there's like supports tablet true, URLs to the icon, whether or not, what the primary color should be. That's the primary color of the actual thing in the Android switcher when you go to the fast switcher or the application switcher in Android, what the header is called. So literally everything that you can possibly configure about an application, exp.json allows you to do that. It used to be that way, but they've been working on this for so long that they've really kind of achieved like full parity, which is really cool. We can go to the next one. So how does this work when you're actually publishing the application? Because we've just talked about how you develop. You get logs for free. You do have to like import Expo, but when you're actually published, what you're able to do is you're able to either, I'll start over here. You define your different slugs and things like that in your exp.json, so that's what I was just talking about. And then you hit publish. What that does is it pushes your JavaScript only files and assets to their server, which then is downloadable via the Expo client. So as we all know, React Native apps, when you hit package, Xcode or Android Studio will go through and will package up your JavaScript files into the bundle that's then delivered to the app stores. But what Expo does is it essentially subsumes that step and makes it so that your JavaScript files are dynamically downloaded. So if there's a new version, it downloads a new version, so you don't have to worry about releasing. We've also talked a little bit about, I don't know if you all saw, it was like blowing up Stack Overflow like 3 months ago. Code, I don't remember the name, what was the name of the code push?
It was some other thing.
Some other thing, but code push, it was like doing dynamic code execution. Expo does not do dynamic code execution, it just downloads a new bundle. So it's very different and it's not dangerous to use. It's also supported by Facebook, but what it does do is it allows you to update your application dynamically. So you basically make a wrapper, and that wrapper application is targeted at your URL, which usually has like an @ symbol, the name of your company, and then a slug. So you can see over here, this slug is fit edge. The application's name is fit, stands for something. So that points to here. This wrapper, which is launched into the App Store, enables you to actually have that download. It's targeted specifically at a specific bundle. But the Expo client, which I just kind of showed, but I'll kind of just show you guys the launch screen of it, it allows you to choose which one you want to launch. So the wrapper is basically hard-coded, which enables you can see here, this is a list of the different applications. The wrapper is just hard-coded to one. When you push a new version, it pushes onto their cloud. Whenever the user opens it, and it's very easy to do, they just click the icon, it will either, if it's offline, it launches the one that it has. If it hasn't downloaded a new version, it launches the one that you packaged it into the App Store with. And if there's a new version, it downloads the new version. So it's very flexible for doing new releases. And it obviously builds wrapper apps for both APKs and IPAs, so you can do it. So we haven't even talked about this at all, so we're kind of jumping ahead a little bit. But we also deployed this application on Electron, which is obviously a desktop. How many of you use Electron? Cool, so not a ton. So Electron's really awesome. It's a way to use React apps to use kind of React Web more than React Native, but you can use React Web applications to publish those via a, I guess it would be like an exe wrapper or a .app wrapper for Mac and Windows. And so we also had the requirement that we would launch our application on the desktop platforms. And we did achieve some code sharing there, although this is a different repository. We did talk a little bit about doing it in the same repository, and the main reason we decided against that was less that we wouldn't be able to share code, and more because it has a different release system. You have to have these be auto-updated. The release cycle for us would actually be very different, for our client would be very different, and so that was why we ended up going against it. But you could certainly put this in the same exact repository, have it just be one big monolithic app that can run on anything you want. The high-tech way that we shared code was to copy and paste React Native Web compatible views. So again, things that use that view and text and all the other things that can then be rendered on either platform. So we could do Git submodules and things like that, but we did the highly advanced method of copy-paste. But in the future, obviously, we could make those Git submodules. So we have some screens that recap data that are really complicated, and they use React Native Web views to do that. So this is how we deploy that. Obviously, people have the expectation that desktop applications are auto-published and auto-updated. And the way that we do that is using something called Squirrel. Squirrel is a kind of Windows focus. We're targeting Windows. So Squirrel allows you to have your applications be auto-updated, basically issues mobile events that are then caught by your app, and they say like, I have an update ready, I have an update ready to install, and then it restarts and then it'll install with the installer. So the benefit there is, of course, that again, across all the different platforms that we have, and this is obvious for web, but across all the different platforms that we have, you're always on the latest version. It's really important because for things like payroll, there was an adjustment to the payroll logic. You cannot have someone bill like an hour that's not with the correct logic, or else apparently the union will come down and do other things like that. So I think that that's very important. So Squirrel has a very creatively named Nuts server that allows you to post new releases. It harnesses the GitHub release, so this is a screenshot of a GitHub release. What that allows you to do is to make these releases immediately available to the Squirrel server. So basically by hitting the publish button in GitHub, that's the front end. That was really cool. This was difficult to set up, I'm not going to lie, so if any of you are interested in doing that, a lot of the example code that's out there doesn't really work right, or it takes a lot of work, so let me know, I'd be happy to help, or let us know. That's not to say that it doesn't work great, it absolutely does, but just for whatever reason, a lot of the documentation wasn't super great. So we've talked a lot about React Native Web. I just want to really expound on this point because this is super important to understand what we did. So the way that React Native for web works on web is, again, it's alias, so you require from React Native, but you're actually requiring this other library that this wonderful person named Nicholas made on GitHub. And what that allows you to do is it essentially is just naming a React component, view, and then when that renders, it renders a div. And if you require components from React Native like platform that have no significance on React Native, or sorry, that have no significance on React Web, it'll just not render anything. So that's basically overriding the other components. And so that enables you to import anything you want from React Native without worrying about it actually causing a problem. You do have to like say, you know, if I'm on web, do this. If I'm on native, do this. You have to do that sometimes, but we didn't have to do it too much. And the main reason is because of React Native Web. So it's either going to render a native UI text view or on Android a text view, or it's going to render a span. So that's how React Native Web works. It's pretty awesome. So I want to talk about, sorry, I was covering it up, that was bad timing. I want to talk about some gotchas. The biggest thing that I think is important to note here is that this project involved a lot of discovery and a lot of procedural enhancements to what we've learned on and built on. So the kind of cascading styles model that Ty covered was kind of an innovation that sprung out of learning about, hey, how can we use React Native Web? So we kind of have continued that into our configuration. We now have company-specific configuration that cascades. So like the default behavior is this. For this company, do this. For this company, do this. That's not rocket science, but we kind of have cohesively built things based on that paradigm, which I think has been pretty cool. So, this is obviously what I'm talking about here. If you're used to React Web, you're not going to be used to React Native styles. They are based loosely on CSS, but they're not the same. I won't go too much into that, but just suffice it to say that there's some crazy stuff like what does flex 0 mean? What does flex -1 mean? Those mean special things in React Native. They don't mean anything, obviously, in the native HTML flexbox or CSS3 flex. So you just kind of have to think differently when you're using styling. And again, this is what we talked about with you cascade the styles. We kind of stole that from CSS. We were like, let's pick the cascading part. Let's not pick all the nuances of CSS. So that's essentially defining your base styles. And then you define I want it to be a native-only style, and then further I want it to only be an iOS style. You even have I only want it to be a tablet style. Yeah.
How many of those edge cases did you have to come up with?
Not a ton. I mean, there's not like, I wouldn't say there's like, for most screens, there's maybe like 1 or 2 declarations that are like native specific. There's very, very few that are iOS and Android specific. We did need them sometimes, but it usually has stuff to do with like, Android has a slightly longer top status bar. You know, iOS is 20 pixels, Android is 30.
You mentioned Flexbox. Is that like an equivalent of auto layout for?
Yeah, that's exactly right. So Flexbox.
It works the same way, or?
Not the same way, but really similar. So like Flex Direction says, I want my objects to lay out in a row or a column. And then you can have like this object should grow, this one shouldn't. It's kind of out of the scope of this talk talking about Flexbox. If you know it. There's a lot of awesome tutorials. It doesn't work even exactly the same on React Native as it does on web, and that's not.
So let's say you can deal easily with different orientations and screen sizes.
Yeah, it's exactly right. It's to the extent that we normalize it, we normalize it as much as we could. So when we use Flexbox, yeah, it tends to behave pretty much exactly the same. And yeah, you can say like this should be 25% of this view, this should be 75%, so on and so forth. So that's what we did. So performance, right? React Native is you always have to worry about performance, and you have to worry about things on the Android being slower than things on iOS and so on and so forth. Obviously our application, you haven't really seen it because again, we can't really show you everything, but it renders a lot of views. So performance really matters. And one of the biggest ways that we did that was with React Redux bash action. So if you use Redux in your application, you obviously use the dispatch paradigm to use an action creator to make an action, which has a type and maybe some metadata to dispatch an action. That's great. That's another thing to learn. But once you learn that, what you also learn is that those things are synchronous. They fire off like one at a time because they modify state. So if you don't fire them off quickly, you're going to have it be basically waiting and looping for a long time before your component is re-rendered. Or worse, it's going to re-render your component every single time it updates the state, which is actually the default behavior. So that's a huge pitfall. So a lot of people are aware of this, and so there's some really, really widely used things on GitHub basically to address this problem. The biggest way to do that is with this thing called Redux batch actions. And that basically allows you to push all of your actions into an array and then fire them all off at once. And that causes a single re-render of all your connected or smart components. And that's a really important difference between doing it for every single thing, because when we're rendering our dynamic forms, we might have like 30 to 40 fields that all would be rendered once, which would be a one-time render for the, so our component basically would update like 60 times if we didn't batch the actions. And for obvious reasons, that would be very slow. So one of the biggest ways we optimized the app, and we were aware of this starting out, but like that was one of the biggest ways we optimized it was to batch the actions. The other biggest way is to note that like different JavaScript runtimes and implementations just don't always work the same. So clone deep, which basically says, I have a big object, and I'm going to say copy every, deep copy. That was incredibly, it was fine on iOS, it was only about 3 times slower, but on Android, it was like 6 seconds. That was for copying like a very basic object that only had maybe 4 keys and like the sub keys maybe had like a couple of arrays. So
This is the Lodash implementation.
exactly, sorry, yeah, this is the Lodash implementation of clone deep. So watch out if you're using the Lodash implementation of clone deep on Android. But JSON parse, JSON stringify the same object, which does the exact same thing, but obviously doesn't work if you have functions in your object, as your object's values, I should say. That was 93 milliseconds. So like, JSON parse, JSON stringify sounds out of the box like that would not be fast, but it's way faster, and we knew that we weren't copying the complex data types like dates or functions. That was what we managed to do there. You can go ahead. Also, yeah.
Batch actions.
Sure.
So those will still execute in exactly the order you call it. You won't end up with weird optimization race conditions or anything.
Like 95% of the time. Sometimes, like once in a blue moon, you'll find that like state didn't have something that you expect. So we don't use a lot of state because we have to hire our components that pass down props. But if you're using it with state, or worse with React's context, which like probably shouldn't be using anyway, but or at least I think. If you're doing that, sometimes, but again, it should execute. For example, like if you do a dispatch of a batch actions of like 50 actions in an array, and then you dispatch another action, all of the things in the batch will have already executed. But it's if you have things in the batch that aren't aware that they're being batched together, they do execute in order. But for example, if you have an old action that had never been batched before, it didn't expect to be ran in a batch. You basically have to watch what order you push them into the batch. So if you don't push them into the batch in the right order to have the right things updated, it will be totally surprised. You have to be, but that's kind of the developer error, right? Because you have to be able to, if you write your application knowing that you're writing batch actions in the beginning, you probably won't. So tests, everybody, it's on the final frontier. Whenever you do something cool like this, where you write an application on every platform at once, you would love if you could have tests work perfectly. So I'll just talk about, I know we didn't make it perfect, but I thought we did a pretty good job, especially with things that are easier like unit tests, because obviously that's all the stuff that was in that common directory that Ty mentioned. Those are things that are in utils. That's like, did this use the correct business logic? So that was easy. And obviously you should use utils, because then that makes that easier. For functional tests, it's a little bit harder because you have to say, okay, is this component going to render the right thing? If you were using all of your tests matching on a class name, you don't have a class name in native. So you kind of have to be, and again, obviously you're all sitting here today listening to this talk, so if you were going to use a strategy, we want you to do that. So you wouldn't write a functional test that would key off of whether a class name has been present in the test, which is the usual method. So just again, be aware, if you have old tests or if you're using a generator, a lot of the time they'll generate and they'll say like, does this have the class name? Your generator is probably not going to help you in that regard. So don't over-rely on your generators, because again, you have to write a lot of custom stuff. For integration, meaning what I mean by that is basically checking your actual like DOM or your React Native views using some of the things you might have seen that like Airbnb puts out, like Enzyme. That's a lot harder. It's not impossible, but for the purposes of like staying on deadline and all the other things, it's pretty difficult to say, okay, I'm going to deeply test every single one of my components. But that's not the end of the world, because obviously we are sharing a lot of code, so we get a performance gain there. And we also, when we do QA it on one platform, we're pretty confident that it's going to work on the other platform, especially when it's something like business logic. So that actually wasn't a huge problem for us, but just be aware. So that's the end of like my particular slides, but I do want to just talk about a couple other things, a couple other gotchas. The biggest thing was like, how do I require platform-specific code that just isn't going to work? How do I require, like, I need to use the React Native camera? How am I going to do that? That's not incredibly difficult, but you might need to do something creative, like require a local file that then does a module export depending on the platform that you're using. Just like that code was kind of the most wonky stuff. There's like a very small percentage of the code base that ends up being kind of wonky.
When did you get to use those in this example?
In this example, we use like the camera and the file picker.
NDA.
Sure.
For like what? Like,
Oh yeah, for like taking pictures. I mean, for like uploading.
so you would be like iOS.
We talked about expenses, right? So this is
Right.
picture versus.
Okay. Thanks.
How do you deal with the different states of the app that you have in the mobile that you don't in the web? Like, for example, when the app goes in the web now,
Right.
if you look at the perform tasks specific for mobile, how do you deal with that?
So Expo, this is kind of something that I do feel like I kind of glossed over. I'm sorry about that. So Expo, I'm glad you brought it up. Expo basically is a bridge between portions of the React Native application that's running and things that you would ordinarily do, like an RNPM link to bring in like a native statically linked library, dynamically linked library. You don't do that because Expo is trying to give you everything that you would otherwise need. So you do have to, like, if you're looking, I need to use like a canvas for this, or I've got to like, you know, bring in a photo picker, or I've got to do something that integrates native. You do need to find to make sure that that's JavaScript only, which is pretty much everything at this point. Like, we benefit from having an ecosystem that's had like multiple years of development on Expo. Expo was launched, they started about 2 years ago. They built a lot of their own components. At the beginning, they didn't have a photo picker, now they do. So, I mean, they knew that. That was prior to 1.0. So that was kind of not, like, sorry, so your initial question was like, how do you do that? Expo provides an event listener that can listen to the like application foregrounded application background. It's all in the Expo docs, which are great. And they have a Slack channel they're highly active in. So I was confident because I had used them at my prior job when they were much younger. And so I kind of knew like how involved they were and how passionate they were. And it was a little bit of a leap, but I was very comfortable and like, it is more than worth it. But yeah, I could have done that with it. But they have everything you possibly needed, to my experience so far. Sometimes file extensions need to be JS on some platforms or JSX on web. It's kind of weird. Like what Babel RCs are really funky. So like if you're using Babel, which we do, we have some Expo only branches that basically have like one commit that sits on the top that has like a custom Babel RC to get Expo to use. But that's kind of just that's a lot of that's from earlier in Expo's life cycle where it was pretty specifically like, hey, you have to have this configured exactly. They've cleaned up a lot of those, and so again, like this would be a lot easier today than it was when we first started. It was still pretty easy, all things considered. So that's, I think.
When did you guys start this project?
About 11 months ago.
Yeah, I want to say we kicked off probably the first week of October.
And it's launched now? Or-
Yes, it's ongoing development for new clients,
Cool.
but it's launched.
It's a constant rollout.
Right, right.
Were there any close calls where you thought you might have needed to eject to native code? Or if there had been, like what would the process have been like?
Sure. No, there weren't. Honestly, I'm grateful for it. I'm not going to say that you wouldn't. We kind of really thoroughly understood the platform space, and web had actually been built on a little bit before making the decision to go to native. So, well, not much, maybe a couple, 3 weeks, but like enough that we kind of understood the problem. I think if we needed to do something absolutely crazy with like iHome or like Android Home or like you know the accelerometers, well, even the accelerometer is fine though. I think if you need to use like a brand new feature like VR, like the VR measuring thing that I just saw on iOS 11, that's super cool, but you're not going to get that with Expo. But like that's not what we're doing. So we do that. We're largely, it's basically a data entry app. But if you're trying to make like, you know, a controller for like a drone, that this may not be the choice, although you can still probably do it. I would just say you do have some trade-offs if you're going to try to launch on every platform at once. But the trade-offs tend to be like, we just can't do the latest and greatest. But there's still stuff that Expo has released since we started. Absolutely, it still could come along. Yeah.
Did you guys consider doing a progressive web app, or is that not far, it doesn't go far enough into the like internals of operating on different platforms?
Yeah, there was going to be a upfront requirement that everything, they are very particular about
Gotcha.
very different clients needing to use. For example, the reason we couldn't is because some of their clients will be given, Android phones that they specifically are asked to enter their hours on. All of these construction workers are literally coming from flip phones, right? They have no conception of how
Sure.
technology works. So we were kind of pigeonholed and being forced to use various kinds of platforms as needed, and it just so happened to be everything you can imagine.
Yeah. Well, just because like with a progressive web app, you could conceivably build this thing to work on all platforms, including Electron, in one release, right? But there's like, the download is a little different, and you can't access all the features that you can get into React Native, I imagine. I don't know that for sure, but I'd be curious.
Yeah, I think one of the biggest reasons why we chose to use Expo was kind of to try to avoid like, we've got to make our own connection to the camera. It's like, that just works. And,
Okay.
That's just the thing that you just import camera from Expo. So that was kind of, and again, that was based on trust of them.
Yeah.
The fact that they were backed by Facebook. Conceptually, we might not have gone that direction.
There
was a comfort there.
They're actually part of Facebook, right?
Yeah, they're actually part of Facebook. So obviously Facebook is React Native. So that was the other reason.
Yeah. And we personally know quite a few people on the team, so
Right.
I get those.
And that would just be a broader comment. Like, if you're going to do something, especially in production, like, be really comfortable. If you're really comfortable, go for it. If you're not comfortable, don't do it. I think yours is up first, sorry.
Do you have any components or libraries that you would like to, that you could abstract that, because it seems like your use case is very different, but would be useful to other people to collaborate with? Or is
Totally, no, it's great.
Yeah, no, we've definitely talked a lot about that internally. There's, so we haven't really gone into the Electron application too much, just because it would take a long time to go through that. But even internally for our purposes, there would be times where it would be applicable to kind of abstract something that we have internally, a mechanism that we use to be something that we can then share between other applications that we're building, both for this client and others. So we don't have anything on the table in terms of concrete things right now, but it's definitely something that we've talked internally a lot about, and had a couple of fire debates about the merits of doing this now versus later in the thing. So it's on our roadmap for sure.
For some concrete examples of what those might be, I would just say like the styling engine that you saw. Some of the things that we've done, a lot of the screens that we've made in Form Builder. You saw the things like basic info wrapper, things like that. That would essentially be like an alternative to Estate, right? But or however you pronounce that. But no plans at this time. But those are the parts that we've always kind of thought, yeah, those could conceptually be.
Question here. Did you try doing any sharing of the communication layer, like use a REST API, Graph API, or any socket?
Yeah, that's all shared among all the clients. Yeah. So the communication layer is via REST API. We did cover that, but it's all the clients, including the Electron app. They all use the same one, and they all use the same routes. That's all in common directory. So like, there's an app API, there's data models, and all that kind of stuff. That was actually a huge. We didn't cover that at all because that was like so nice. We didn't have to worry about that at all. The fact that like the data models and the way that gets down into the reducers, that was all common. And that, I think nowadays we kind of, the last slide I'll have on my little notes, which I think is a good point to cover now, is that like, when you try to do something like this, I'm going to launch an app on a lot of platforms, there's a lot of like upfront configuration, understanding the tools, and like dealing with the pitfalls and all that kind of stuff that we tried to cover. And you kind of have to do that for a while. That could take a decent amount, but then you have a lift off, and nowadays it's like we can add a new screen in like a day, which is really fast and awesome. So like your time to lift off could vary depending on your skills and the skills of your team. But like once you achieve that, you really are at a point where I think it's totally worth what we did. And
for context, to give a specific example, in the last month, we have been able to add more screens for different clients onto this application that we have leading up to the entire history. Because we reached that inflection point a couple months ago where form loops were good, our APIs were solid, all of our internal APIs with components and our design patterns were finalized. And now, if we need to add a new page or new component, it's as simple as either copy and paste the API side of things, or we already have a pattern and we're good to go.
it's been very fun to watch that.
Yeah.
So you could time travel back to the point where you started this whole thing.
Sure.
What did you tell yourself?
Yeah, so I don't think I'd say that. No,
So the one kind of annoyance that we experienced, and this is obviously developer error on our end, just because we didn't know any better. We kind of started off just trying to get the website and things good to go. Was we started writing a lot of the components in just vanilla HTML, or rather JSX, right? So you had our div tags and H1s and all that fun stuff. And later on, we found that we needed to then go and just share that code. Like, oh, it'll be easy. We can just like, we already have the skeleton of like the JSX or the HTML. We can just swap a view out and span out the styles. And that actually turned out to be a pretty involved process. So I would say that if we had stuck with writing React Native web code, or rather React Native code from day one on all platforms, it would have made our lives a whole lot easier. There's definitely a time sink that I have to go back and redo that a little bit later on, once we understood the problem a little bit better.
Yes.
What would you say, Colin?
I would agree. I mean, I think like if we had just kind of thought, the biggest thing that I would go back and tell myself is like think React Native first,
Yeah.
and then that'll go into web. And that's not inherently obvious because like, especially if you're a React web developer, you're like, well, what's wrong with that? We could go the other way. I think the biggest, I didn't intuitively know like it would be easier to go one way or the other. And now, especially because we chose the React Native for web implementation, like that was the right way to go. But I think that's more just because things like Vue, text, things like that, they are like abstractions of iOS and Android views. And then like whereas P and div is like literally just going to be rendering that HTML DOM component. And so, there wasn't like a gigantic thing that was at the beginning of the project, but yeah, we did have to rewrite some SCSS like down into the styles objects, or kind of make things that we could have very easily made common if we started with them being common. That we decided to say, like, we've got a lot of custom SCSS here. Let's just make this a web only. Let's make this what we call an @universal component. Let's make a native version of this view. And we could have theoretically made this common, but right now it's just easier, just like because of the custom SCSS written.
So you're saying that HTML cannot boil down to React?
No, you gotta go the other way.
Thank you very much.
Yeah, sure.
What is the whole build cycle and release? So you said like we could release a new frame in a day or a new page in a day.
Right.
Just kind of, I'm curious, like you kind of touched on a lot of pieces of it, but what's the whole thing?
Yeah, I mean, basically a module config defines a special form that has a text input.
Sure. I guess I mean more on like the DevOps side. Let's say we've got the code written, just take that for granted and just say like, how do we get it out deployed to like different devices, and including electron app and web app?
Great question. So we have our modules that we refer to, those are essentially screens. So one module is one screen. And we have in our config, it's just a lot of text, so we don't want to throw it, but things like visible pages define what's available in the menu of the app. So like we have a hamburger menu, like you might expect. And what's visible in there is controlled independently of the module's configuration. So basically when we decide, hey, I'm ready to launch this screen, we just put it into visible pages, right? And then it's delivered to the client. Now sometimes you have to do a front end, a lot of the time you have to do a front end release to deploy that. So that's it. But you could conceivably send the front end code to the client and then release it via the API, like at a later date. And it would be on the client, but they would have no way to access it, so they wouldn't know.
So you have some like back-end feature flags kind of going, or feature toggles?
Yeah, exactly. But the broader point here is that everything is continuously deployed, because like web is obviously continuously deployed, but Expo allows you to continuously deploy even in production. And then the Electron Auto Update allows you to deploy that on that. So everything is continuously deployed. So we haven't really had, and this is a good thing, I think, we haven't really had like, this is a gigantic release day. We've been able to stream releases, and the laborers don't even know, and that's intentional. That's I think even like 2 years ago, that wasn't really exceptional. To be continuously deploying every single platform we're doing, and that has been probably my favorite thing about this app. It's like when we need to release a feature, we can just push it. It's super easy. So like, we just have a staging branch, we rebasing it master, there we go.
And so it, like Circle CI builds your stuff,
Exactly.
runs the tests, and then does some kind of build scripts, and then that pushes it out to I can't remember what the packager is called for the iOS and Android.
It's called EXP, so yeah,
okay.
it's got like EXP build, EXP publish, those kinds of things. And yeah, that basically sends your JavaScript bundle, all your JavaScript files, like to S3 servers, and then your application knows to download that.
That's
so,
cool.
Yeah. And when it starts, it does have a little bit of a spinner, and that's it downloaded to JS bundle. So you got to keep your JS bundle like kind of small. But again, a lot of these folks are in offline situations. They're in construction sites. They might not have sell. So we do need it to run the offline one. So that was the biggest thing that I made sure of was, does this run offline? And the answer is yes. So it'll use the cached latest version. Any other questions?
Anybody else have a question?
I know we have time for you.
Okay, cool. I think that about sums things up.